Okay, let's do another example. This is actually in class number 12. So it says let S be the parallelogram with vertices at P0 equal to 1, 0, 0, P1 equal to 0, 3, 0, P2 equal to 0, 1, 1, and P3 equal to minus 1, 4, 1. So this will be a parallelogram in 3 space. So let me draw it. Okay, so I've drawn it here. So again, I didn't try and draw it in 3 dimensions really, just threw it into 2-dimensional board. So I'm not trying to get it perfect. But note here that P1 minus P0 is minus 1, 3, 0, if you look at the points up there. And P3 minus P2 is also minus 1, 3, 0. And that should be the case because these two sides here, so this side, should be parallel to that one. So we've shown that. And you can check that these two sides should be parallel too. I won't check that, but let's keep going. Okay, so I want to find a mapping R that maps this unit square into this parallelogram. So it's always possible to map the unit square into any parallelogram. Okay, so we're going to use an affine transformation to do that. So let me write down a definition of the affine transformation. So a transformation would look like this. So it'd be A1U B1Vs plus C1, A2U B2V plus C2, and A3U B3V plus C3. So let's map say 0, 0 to P0. So we're going to want here that, so we want R0 to equal P0. Let's also make say R of 1, 0. Let's send that guy to P1. Let's send R of 0, 1 to P2. And then R of 1, 1 should go to P3. But as we'll see here, this will be enough to figure out these A's and B's. So let's keep going here. So looking above, our P0 is 1, 0, 0. And now we're going to put 0 in place of U here, 0 in place of V all the way across. Doing that, you just end up with a C1, C2, C3. So then we can conclude that C1 would have to correspond to the 1 here. So it'd be 1. C2 would be 0. And C3 would also be 0. Okay, so let's replace those up here now. We'll put C1 as 1, C2 is 0, C3 is 0. So let's do that. So I replaced my C1, C2, and C3. Let's move on to the next one now. So next one, I'm going to put 1 in place of U, 0 in place of V all the way across, 1 here, 0 here, 1 here, 0 here. So let me do that. So look at this guy here. So again, putting 1 in place of U, you have A1 there, 0 in place of V, the B won't be gone, so it'd just be A1 plus 1. Then it'd be A2 plus 0, then it'll be A3 by itself. So the A1 plus 1 has to equal to 0. So you'd have A1 plus 1 equals 0. Solving it, have A1 then is minus 1. So A1 is minus 1. Then you have A2 would have to equal 3. A2 equals 3. And A3 would have to equal 0. So A3 is 0. So let me replace those. So I'm going to put a -1 in place of the A1, 3 in place of the A2, 0 in place of the A3. Okay, so I've done that, made the substitutions, and our last one we have R01 equals P2, and P2 is 0, 1, 1. So let's see, so we're going to put 0 in place of U, 1 in place of V, all the way across 0, 1, 0, 1. So doing that, Doing that will get b1 plus 1 because it 0 in place of u, 1 in place of v, so you have a b1 left there plus 1. Then 0 in place of u, that'll be gone. 1 in place of v, just be b2. And then 0 in place of u, 1 in place of v, b3. So then you have b1 plus 1 has to equal 0. So solving that, b1 would have to be minus 1 there. So b1 is minus 1, b2 is 1, and b3 is 1. Okay, so making those substitutions up here for b1, b2, and b3. So I made the substitutions, so we found our R mapping now that maps our unit square into our surface S. Okay, so let me erase a few things and keep going. So there's my R of uv. So let's find derivative of R respect to u. So it's going to be minus 1 here for the first component. Then here it'd be 3. There's no u here, it'd be 0. And let's do derivative respect to v. So it'd be minus 1, 1, 1. Now we're going to do the cross product. Okay, so here's my definition of cross product. We're doing RU cross RV. Okay, so let's do the I guy first. So it will be then three, 0, 1, 1, I, then minus to the J1 next. So it'll be minus 1, 0, 1, J, and lastly do the K. So it'll be minus 1, 3, 1, K. Okay, so this will become then 3I here. And that'll be plus J and that'll be minus 1, minus a minus 3, so plus 3. So it'll be 2k here then. Okay, so now let's start doing the double integral. So summarizing is what we have so far. We found our R. We did our RU cross RV. Here's our D region. Here's our vector function. So we're now trying to find the flux of F across S, where S is the parallelogram from the beginning. Okay, we know it's then equal to this from the 15.6. So let's start filling this stuff in now. So then this will equal, well, our D region is over here, so 0 to 1, 0 to 1. That'll be f of r, u, v. Here's my f up here, so it's x. But looking up at the r, the first component here is the x. So it's going to be minus u minus v plus 1. So it'll be minus u minus v plus 1 times z. Z here is my v. That'll be I direction plus z. Z here is v, so it'll be v j plus y. Y here is 3u plus v. 3u plus v. K direction. Dot it with our ru cross rv, which is 3i plus j plus 2k. So dot it with 3i plus j plus 2k du dv. I could switch those around, it doesn't matter since we're integrating over a square here. Let's keep it as du dv. So we got to there. So now let's do this dot product. So we'll go 3 times the, so multiply the I components, multiply the j components, multiply the k components. So doing that we get, so doing dot product we get this, so it'll be 3 times this guy, v, and 2 times this. So then multiplying this in, we get then 0 to 1, 0 to 1, so it'll be minus 3v squared. minus 3uv plus 3v plus v, multiply this in, plus 6u plus 2v du dv. And then so combining some like terms, well, I can combine the v's here. So doing that, so we get to this then, combining like terms, and now we're going to integrate with respect to u. So let's do that. So it'll be integral 0 to 1. So first one will be minus 3v squared u. Integrating this with respect to u will be minus 3u squared v over 2 plus 6 uv plus, it'll be 6 u squared over 2, so it'll become 3 u squared, evaluated at 0 and 1, then we'll do our dv. Now we'll put 1 in place of u here, here, and here, here, and put 0 and it will disappear. So doing that, we get this. So putting 1 in place of u here would be negative 3v squared, 1 in place of u here would be 3v over 2, 1 in place of u here would be 6v, 1 in place of u here would be 3. So then integrating this, so integrating minus 3v squared, so it would be v cubed over 3, the 3's will cancel to become minus v cubed, and this will become v squared over 2, is already 2 down there, so it'll be minus 3v squared over 4, and this will be v squared over 2 has become then 3v squared. 3v squared has become 3v, evaluated at 0 and 1. So I'm going to put 1 in place of v and work it out. So we'll bring it up here then. So right here. So I put 1 in place of v cubed here, so it just becomes negative 1. Put 1 in place of v here, it becomes negative 3/4. Put 1 in place of v here, it becomes 3. 1 in place of v here becomes 3. Then common denominator would be 4. Change everything to fourths. This will become negative 4, negative 3. That'll be 6. So it'll be 6 times 4. Then adding that, we get 17 over 4 is our answer. Okay, so we're done.